debugging here in this wonderful venue at Samsung R&D campus. So we've got a very, very exciting program, and we're going to kick things off with our first keynote on the status of ONOS. So please join me in welcoming Guru Parulkar.
Good morning and welcome. Let me get my clicker and we can get started. So thank you for coming and participating in the ONOS build. It's a real pleasure to welcome you all and all your participation in ONOS, not only in this event, but all the contributions you have been making to ONOS. So I really appreciate that. I also want to start by thanking Samsung, who has been the host of this event, and as you can see, excellent facility. They provided excellent support to get everything organized, and so we really want to thank Samsung and Sohain for what they have done. Of course, Samsung is also an ONF partner, and they've been supporting ONOS, COD, and all of that, and we are thankful for that as well. We also have other sponsors who have been supporting this event. SK, Fujitsu, Huawei, SDN NFV Forum, Adara, KISP, Mobigen, and then ON.Lab as the media partner. So again, thank them as well. So I think I want to spend the next half an hour to tell you about the state of ONOS. And I thought the best way to do is to summarize the most important points at the front, and then if you want to tune out, you are welcome to tune out, and I will go through some of the details. So I guess the first thing I want to say is that ONOS is on a path to become a critical platform for service providers, okay? Especially when it comes to the edge of the network or the future edge of the network. Clearly in the context of COD and COD-related edge applications, ONOS is probably the only SDN platform that has the traction and the attention and the mind share of the community, and it is quickly moving into field trials and production use. Okay? The second thing is, of course, we have been, thanks to you all, we have been making great progress with ONOS. And when we think about progress, we think of them at least in three areas. One is ONOS as a platform itself, and there we are looking at features, functions, maturity of ONOS as a platform that can be deployed. And the next thing we look at is what are the use cases and solutions that people are building with ONOS as a platform. Because as you can imagine, ONOS as a platform by itself is not that much value. When you build use cases and solutions based on that, that is when it becomes really useful to service providers, and we see a lot of that happening as well. And then of course community. It's an open source project, and so the success of an open source project in the long run depends on the quality of the community and how community is engaged, how community is diversified, how they are continuing to participate and contribute. That plays a very important role. And as I will show you some data and you may be familiar with, that we are doing pretty well in terms of growing the community, keeping the community engaged, and all of that. At the same time, I don't think we can say we can declare success and go home and be happy. We still have a lot of work ahead of us. And again, when I talk about the work, there are two areas where I believe that the work is most important. Okay? So the first one is, now that ONOS is mature to the point it has, the next big thing is, can we really make it production ready, and can there be commercial offerings of ONOS that the industry can count on and depend on. Okay, so that is one very important thing. And in that area, I would say that we still have some work to do. And one of the reasons that it is moving slower than usual is that ONOS, if you look at it, is bringing a disruptive technology or solution to the field of networking in terms of the disaggregation, white boxes, and all of that. And when you bring such a disruptive solution to the marketplace, it does take longer for it to be absorbed and mature and be ready for production deployment. Okay? Another thing, as I said, in the long run, success of an open source depends on the community on a longer term. You cannot build a community for 6 months, for a year, get everybody excited, and then if the community doesn't stay engaged and continue to participate, it cannot sustain, and we cannot have ONOS continue to be a viable platform for the industry. And so that is the second important area where we have to continue to work. So I think these are my high-level takeaways, and then now I'm going to just focus on details, and you can decide how much you want to tune in. But I think one more thing that you should tune in before you may want to tune out is, I really feel that ONOS, ONF almost have some kind of a love affair with Korea. We work with many, many geographies, but if you look at the amount of participation, contribution that we have seen from Korea, it is pretty amazing. And the organizations that have been mostly participating and contributing are listed: ETRI, KAIST, KHU, KISTI, Postec, Samsung, SK Telecom, and there may be a few more that I apologize if I am leaving them out. And if you don't believe me, if you look at number of contributions that are coming from Korea into the ONOS and ONOS-based use cases, it's really, really impressive. Okay? And we really appreciate that, and I want to thank you for, again, your participation and contribution. And that is one of the reasons we decided to come and bring ONOS build to Korea. Of course, thanks to Samsung for hosting it as well. But because of this level of participation and contribution, it made a lot of sense. Okay? So now in the next 25 minutes or so, what I want to follow is this particular agenda. I want to give you a little bit of an idea about this larger organization called Open Networking Foundation. If you are paying attention to it, you may know that we used to have two organizations: Open Networking Lab, that used to build open source platforms and solutions, and that is where ONOS started, and Open Networking Foundation, that used to standardize open flow protocol and evangelize SDN. During the last 6 months, we decided to bring these two organizations together. The organization is now called Open Networking Foundation, but its mission is a lot more aligned with the old Open Networking Lab mission, which is to build open source platforms and solutions for the industry. And I want to give you that larger context so that you understand where ONOS resides and how we are approaching having an impact on the service providers and their network. Then the second thing I want to focus on is the contributing to ONOS. That is talking about what we are doing so you can be more effective, you can be more successful, and we want to hear back from you what we can do to make you more successful in contributing to ONOS and taking your ideas into production network and having a real meaningful impact. Okay? And then I will talk about the state of ONOS in terms of platform, use cases, adoption, and the community. I should mention that I have an in general tendency to pack a lot of material, and when we are talking about ONOS, there is so much to share, and I'm very excited to share this all. And so it will depend on how much time I have. I might go through some of this material very quickly. Okay? So that is the plan. I hope so far I'm communicating, it making sense. Okay? Okay, so let me start with Open Networking Foundation, the larger organization. So this is kind of our mission statement, and for some of you may say, oh, every organization has mission statement, how does it matter, right? But it is very important to know what do we stand for, and what we are really trying to do is to help service providers or network operators transform their networks. And what really they want to do and what we want to help them is to transform their network into what we can say platform for service delivery. Okay? End of the day, networks are not particularly useful unless they deliver services. If we are end customers, either residential or enterprise or whatever customers we are, we care about services that the network delivers. And what the service providers and network operators want to do is to more and more turn their network into a platform for delivering services. And when they do that, what they want to do is to leverage disaggregation, that is merchant silicon, white boxes, open source, so that they can reduce the capex, they can reduce the opex, and still have programmability so they can create more innovative services. Okay? So that's what we're trying to do as part of Open Networking Foundation. And of course, we want to work with the larger industry so that it is not something ONS is doing by itself. We are trying to facilitate and help the industry go through this transformation as well. Okay, so as we try to do this, here is another slide that very nicely captures how we are doing it, what our challenges are, and how to think about the big picture. So if you look at the left side, what is shown there is a closed proprietary box. So today, if you look at any service provider or network operator, what they will tell you that we build our networks with closed proprietary vertically integrated boxes that are not programmable. They bring high capex and opex to the service provider. And as a result, it becomes very difficult to create new services, new innovation on top of these boxes. So what we have been doing for the last 5 years or more, and that is one of the appeal of software-defined networking, is to leverage and to build platforms using disaggregation, that is, break these boxes into forwarding plane and the control plane. Forwarding plane can be realized using merchant silicon and white boxes and open source. And then create solutions that the service providers can use and deploy. But when you try to do this, there is a huge inertia because our networking industry has existed for 40-50 years. It has operated in a particular way where vendors have dominated, vendors create these boxes, and that is how our industry has existed. So you bring about such a fundamental or disruptive change, there is a lot of inertia. So how do you overcome this inertia? So we are taking a two-pronged approach. So one pronged approach is, end of the day, it is the network operators that deploy these boxes. They are the ones that operate the network. And as a result, we are working very closely with network operators to create a vision, to create what they really need. And that is kind of what is the push from the service providers or network operators. And then we want to also create a pull in the sense of that, end of the day, we want to work with service providers, and we want service providers to show that they are really interested in deploying solutions based on open source, based on white boxes, and they are willing to spend money on it. So if they show path to deployment, and if they show path to money and revenue, then the rest of the community can step up and really help make this particular thing possible. And so that is kind of the push-pull model we are trying to do and work very closely with the network operators. Okay? So when I say we work with network operators, you can see this is what our ecosystem looks like today. So you will see there are 8 network operators that we consider partners. So those are AT&T, China Unicom, Comcast, Deutsche Telekom, Google, NTT, Turk Telecom, and Verizon. So these are the leading service providers in the world. And when they are our partners, what we mean is that they are giving us serious amount of funding, they are giving us people, they are giving us use cases, and they are showing a path to field trials and hopefully production deployment. So they have a significant contribution and significant stake in what ONS is trying to do. Of course, we also work with a number of vendors. Samsung is one of them. We really appreciate that. Another thing you should look at is the ONS board. And you will see there are some very, very influential people from service providers that serve on the board of ONS. These are the people who are steering the entire industry, and they are working with ONS so we can bring about the change we are talking about. Then of course we have other large ecosystem as well that we are working with. Okay? So now let me introduce this idea of what we are calling innovation pipeline. So ONS is not about distinct open source platforms. So you may, in this context, you know about ONOS. But ONS is not about just one a platform in isolation. What we are trying to do is to focus on this entire pipeline, all the way from devices. So if you look at the lowest end, you see disaggregated devices, white boxes, for packet switches, OLD, for eNode D and radio access network, ROADM. So these are the devices, and we are working with the industry to do disaggregation, enable white boxes, separation of control from the forwarding plane on those devices. Then of course we are working with controller. ONOS is an example of an SDN controller. Then we build solution. So if you are familiar with CORD, that is an example of a solution that we are building that is of course enabled by ONOS, but also with the disaggregated devices. And they will build virtual network functions, microservices, and then build solution and offer these solutions to service providers. And we put it together so that those end solutions are easier to consume and easier for service providers to take advantage of. And that is what ONS is focused on. Now you may focus on ONOS, but remember ONOS is part of this larger picture, and it enables this solution that the service providers want to use and consume. Okay? I will give you, okay, and by the way, when we bring these pieces together, we are trying to also change the way we do standards. So rather than doing the standard the old-fashioned way, where you start with standard, bring lots of people in a room, spend years trying to build consensus, what we are trying to do here is to build open source solution. And as we build the solution, bring pieces together, we derive the interfaces, we derive those APIs, and we standardize them, and we are calling them software-defined standards. And of course, we are also, as I mentioned, build solutions that are easy to customize and consume by the service providers. So let me give you little more details. So as I said, we are working with programmable forwarding planes with a variety of disaggregated devices. ONOS is the foundation as the control plane. And then we are working with, for example, on the access side, we are working with GPON as well as XGS-PON, and how we bring SDN based on ONOS to that part. We are also working with RAN, especially the XRAN protocol, so that we can bring software-defined networking to radio access networks, building leaf-spine fabric that is used in CORD, but it can be used in other contexts as well, and the packet optical. And then if you go into the context of CORD, we are building CORD as a solution. If you are not very familiar, I will maybe you'll come back, I guess Friday, and I will tell you more about CORD. But CORD is the central office re-architected as a data center, which is a complete solution that there is a lot of interest in service provider, and we are building that as part of ONF activity as well. And there are three varieties of that. The residential for GPON, then mobile for LTE as well as 5G, and then enterprise. And then there's a whole bunch of microservices or virtual network functions that we have implemented, and we are offering that as part of the CORD application and offering them to service providers. And there are 15 or 20 service providers around the globe that are either using CORD in lab trial, wanting to push into field trial, and hopefully into production deployment. Okay? So keep this in mind that when you think about ONM, it's not about individual platforms, it is about enabling the solution and offering the solutions to service providers. And then other people, either vendors, service providers, or third-party software vendors can plug into this and offer their solutions and ideas into this innovation pipeline as well. Okay, so that is kind of the quick overview of ONF. Now I want to talk about contributing to ONOS. Okay, so contributing to ONOS, when you look at yourself or your organization, it is all about, it starts with an idea, and that you want that idea to end up in a production network of as many network operators as you like. And that is the most rewarding aspect of doing work, right? Whether you are an individual, you are a company, what you want to do is transform your idea into something that gets deployed in a production network of many, many service providers. And what we are trying to do at ONF to make it easier for you and maximize the probability of this happening. Because a lot of times people work on ideas, they go nowhere. You may publish a paper or you may do a prototype and they go nowhere. So what we are wanting to do is to maximize the chances of your idea impacting a production network or getting into the production network. So the first thing we did in the context of ONOS is to create this virtuous cycle. You build a platform, you build some solutions, and then you get the solutions, interest from the service provider. And if you look at last 2 to 3 years, what we have been doing is to create this virtuous cycle and get service providers really interested in the solutions that are enabled by this virtuous cycle. Now, during the last year or so, and David and William are the people that are championing this, where what we're trying to do now is to create this idea of brigades. So you can come up with an idea, or you think this is an idea that should go into ONOS or enable a solution going to the service provider. You can either participate in one of the existing brigades, or you can start a new brigade, and as a result, you can move that idea into production network as part of a solution. And we want to make this process as easy and productive as we can, and that is what we are really focused on as we move forward with ONOS. So one thing we are doing as part of that is we are creating something called the use case steering team. So this is a steering team that is led by service providers primarily. Every service provider that is a partner is contributing a member to the use case steering team. So the service providers will tell what are the use cases they care about, what are the ideas and specific things they care about, and that will inform the brigades, and that will inform how the work moves and gets delivered to service providers to maximize the chance of success in terms of getting that work absorbed in the service provider's production network. Okay? So that's what we from the Open Networking Foundation side trying to do to facilitate this and maximize the probability of success for your ideas impacting the production network. So what can you do? So you can join, as I mentioned, an ongoing brigade, or if you think your idea is big enough and it's something that has not gotten enough attention, you can propose a new brigade and you can offer to be the leader of that brigade, and that is how you can participate and contribute, and we welcome you to propose brigades and lead brigades, and we want to help you. And then of course you can participate in ONOS activities more in terms of TST meetings, UCST meetings and other meetings, and that is how you can participate. Now, one of the reasons we are doing the ONOS build, of course there are many other reasons, but one of the things we want to do is to be able to hear from you what you think about what we are doing. So if you think our processes are not working for you, please let us know how we can do better. And almost all the key persons from Open Networking Foundation are here. The ONOS TST members are here. There are at least 4 TST members that are going to be here during this ONOS build event. So give your feedback to David, William, give feedback to me, Asim, Taiman from ONF. There is a TST chair, Thomas is here, Brian is here, Utah, and I think somebody else. There are at least 4 TST members. So give your input, share your input, and how we can do better and how we can make you more successful. Okay? So that is definitely a very, very important aspect of this build event. Okay, so now in maybe 10 minutes or so, I will try to quickly go through the state of ONOS and, at a very high speed, try to tell you what all we have been doing. Okay, so SDN is about, ONOS is about scalability, performance, availability, all of this, I'm sure you're familiar with. So there are 3 things that you should pay attention to when we think about ONOS as a platform. The core, which is the middle part, which is the most important foundation of ONOS that gives us the scalability, performance, HE and all of that. So how is that distributed core evolving? What is happening on the application side and what is happening on the southbound? And so that is one way to quickly understand how ONOS is maturing. Okay? So when it comes to the core, again, maybe Thomas is going to talk more about it or you are more familiar. You can see how when ONOS started, it was pretty bare bones. And over the last couple of years, the number of boxes or number of functions or services that ONOS core offers is growing. Okay? And so that is one indication of how ONOS is growing and ONOS core is growing. I think I will not go into the details of this. Another thing you want to see is on the southbound. Are we southbound even though ONOS started with open flow protocol? You want to see whether there are other kinds of southbound protocol that ONOS is able to support and plug in. And so here is a slide that I prepared some time ago that is showing today. I don't have time to get into it, but you can see all different kinds of, oops, I clicked one more. Okay, so if you look at this, it's pretty impressive in terms of the different types of southbound protocol that people have been able to plug into ONOS. Some of them are very legacy protocols that maybe the pure play SDN people don't care, but interestingly, the vendors have been able to plug these legacy protocols into it. There are some very forward-looking things like P4 and the P4 runtime system that is getting connected into it. There are some XRAN, as I mentioned, as a protocol for connecting, bringing software-defined networking to RAN that are now getting connected, plugged into ONOS. So both a very good mix of old and new that are southbound protocols that are being supported in ONOS. Now when you come at northbound, these are the functionalities you want: L2 forwarding, L3 forwarding, traffic engineering and all of that. And in support of this, there are many functions, or you can call them services or applications, that are being added on top of ONOS over the last couple of years. And this is also a very comprehensive list, and it continues to grow with time. And again, here you will see some very new forward-looking things, as well as some of the old things that people want to do on a network. Okay. Another thing that is very important is the dynamic configuration of devices and services using YANG or a model-based device and service configuration. So this is an area where ONOS was late. It did not start with configuration. We realized that we need to support not only control, we want to support configuration as well. And configuration is different from control. A lot of times people mix them, and that's a bad idea. Control and configurations are very different. So for example, when control, you're trying to specify or modify the forwarding behavior using flow table or flow table entries. And sometimes these things can change millions of times per second. Configuration is we are trying to change the configuration of devices. That is happening maybe a few times a second or something like that. And you need different types of solutions for that. Similarly for services, you may want to specify model-based services and be able to support them. And so this is an area where, yes, ONOS started a little bit late, but the good news is that it's now catching up, and there are many good features. Sometimes when you start late, there are advantages because you understand the requirements better, you understand what you can do, and as a result now ONOS is able to leapfrog and able to provide certain features that some of the other controllers don't have. Okay. Another very important thing is this in-service upgrade. So this is something really becoming a very important feature for production and commercial readiness, and this is starting to become available, and it should be ready for prime time, maybe the next release or the release after that. And of course, when it comes to performance and scalability, ONOS continues to be one of the leaders, the leader in the space. Now we have done 11 or 12 releases, and over all these releases we have either maintained the performance or done much better in some areas. And again, no controller even comes close to these kinds of performance and scalability numbers. Okay, I think I already covered this. When it comes to southbound, we have a good mix of old and new, and lately, at least within the ONF, the focus is more and more on new kinds of southbound interfaces like the P4 runtime system, XRAN, Volta, and these are the kinds of southbound protocols and interfaces that we are exploring and supporting them in ONOS. Okay? Now, as I mentioned, application, there is a whole proliferation of applications on top of ONOS, and there are in different categories. And Thomas tells me that now we have 125 or 126 applications that the ONOS core supports. We are at a point in principle that we can create an app store for ONOS, and then you can use different combinations of these applications or services depending on what you need to do. Okay? I think I will skip that. I suppose this will be, Thomas may cover that. So I think I want to briefly talk about the use cases and adoption. So this is a very interesting slide that I got from Sienna, and I reuse it. So this is the one slide that kind of tells you at a high level what the service provider network looks like. Okay, and you can see there is a wide area core, then there are data centers, then there are many central offices, and across this whole thing, we are trying to bring SDN NFV to all parts of this service provider infrastructure or the network, okay? And so what I want to show is the different use cases that ONOS has been pursuing, and they cover the entire spectrum. So when you look at the wide area network or the core network, either in wide area or metro, we have been pursuing this use case that we call packet optical use case, then disaggregated ROADM, traffic engineering and PCE, SDN IP peering, and then finally the COD, which is in the central office. Okay? So a lot of times when you think about COD, you may think of it as a one use case for ONOS. Okay. However, what you should remember is that there are half a dozen use cases of ONOS that make up COD. And a lot of times we don't realize that. So what I've tried to do is list here the different types of use cases that are part of COD. And what is happening is that each use case by itself is important, and many service providers are taking those individual use cases and taking them into field trials and hopefully production. And you can read the list yourself. Okay? And then there are different adoption for these use cases, and these are the different service providers that are working on different use cases and taking them into lab trials, field trials, and so on. And you can see that list is very impressive. They are across the globe. Okay, so I think I will spend 2 minutes on the community and then I will stop. Okay, so this is the highlight, right? There are approximately 70 organizations that participate and contribute to ONOS. They may not contribute to every release of ONOS, but if you take a release over a period of say 2 years, then you will see there are 70 organizations that have been contributing to different releases. If you take a particular release, you will see 120 or 125 contributors to a specific release. Now we have number of brigades, and we want to really focus on making brigades more successful, and that is how we want to grow the community and the community's participation and so on. Here is the collaborator growth. You can see this. This is put together by David. Very good. Here are different brigades that I think you can learn more. Now we are starting to do some of these more detailed analytics of the community, that where is the contributions coming from. And here is the first, I think just last week, we started to get these dashboards and this data on our community. And the thing you will see that if you take a 1 year view, then there are 214 contributors to ONOS, which is a big deal, and there are maybe 20 or 30 organizations that may be on that list as well. Okay? And then if you take a 2 years, then there are 330 contributors, and the number of organizations grows even more. Okay, so I think these are my takeaways that I already mentioned. So at this point, I'm done. If you have any questions or comments, I don't know whether, William, we have time for any Q&A?
Unfortunately not, but
okay. That's too bad. Okay.
All right. Thank you very much, Guru. Thank you. So one very important point, all the material that you will be seeing over the next 3 days will be shared on the ONOS Build website, so you will not miss a single slide. Now for the second keynote this morning, the title is MMVSDN Transformation. Please join me in welcoming Soyam Chong.
Thank you, William, for the introduction. Welcome. For those of you from abroad, welcome to Seoul, Korea. And welcome to Samsung campus. And welcome to 2017 ONOS Build event. My name is Soyam Chong. I am the head of MMVSDN platform development at Network Business Unit of Samsung Electronics. We are thrilled to host 2017 ONOS Build event and to have a large number of people attending. I think we're expecting about 350 people. Maybe it's too early for the people to attend at this time, but 350 people have been registered. Today, I would like to share with you what we've been doing at Samsung with ONOS in our MMVSDN development. Before that, let me start with giving you a brief introduction of Samsung and Network Business Unit. We are here, Seoul campus. It's about south side of Seoul. It's about 15 minutes from Gangnam style. And the place that I work, Network Business Unit, is located in Suwon. It's about 30 kilometers south of here. And call it Digital City. As you can see why they call it Digital City. It's massive, right? It's about 30 times bigger than the facility, the campus here. Let me give you a brief on the Samsung Electronics business divisions. There are three main business divisions under Samsung Electronics. IT and mobile, consumer electronics, and device solutions. My guess is that most of you know Samsung as a consumer electronics company. You know, TVs, you know, your monitors, and also Galaxy phones. You know, Note just came out, right? But as you can see on the slide, there are many different business units. That includes Network Business Unit. Today, I'll be speaking to you as part of the Network Business Unit at Samsung. Let me give you what drives, let me start out with what are the drivers for MMVSDN? And certainly true in Korea, LTE capacity is ever growing. The capacity expansion. Now the operators have a choice when they need to increase the capacity. They can either continue to support with legacy solution, or they can go with NFV solution. Operators have been asking for service agility, automation. With the NFV and SDN, some of our customers said that their new service deployment time has gone down to less than a month from several months with the legacy solution. That's the rollout time. That includes the pre-validation, you know, post deployment and post-validation altogether. Also technology advancement, also open source community, just like ONOS. There have been large amount of advancement in technology, and especially with the help from the open source community, like ONOS, OpenStack, ON.Lab, DPDK, and also white box hardware solutions, and also 5G. 5G requires virtualization. So what is our Samsung's the architecture look like in a nutshell? They are very high level. It's a software-defined platform with open API, based on open source, with orchestration and management built into it, and also to support platform as a service functionality, such as database as a service, analytics as a service, load balancer, storage as a service, things like that. And with virtualized and cloudified core and RAM functionality, and end-to-end orchestration along with the network slicing, operators can provide a network as a service with a Samsung platform. And the platform also supports basis for additional software development, such as tools, analytics, the customized automation. as I said earlier, technology advancement with the large number of open source community. Samsung's have been part of many open source community. And we are participating actively in some and passively in some others. And just to give you an example, the platform that I shared you in previous slide, the Samsung platform contains about 80% of the code base as from the open source. So very large amount of code base coming from the open source. That includes ONOS, OpenStack, DPDK, OVS, Ceph, and so on. And to give you our participation level and ONOS, because we are in ONOS build event, in 2017, number of contributors, code contributors from Samsung is about 24 people, engineers contribute to the ONOS project and various projects. In 2016, it was 0. And we intend to increase even more in 2018, our participation level. Okay. Let me give you a use case example of what we've been doing with ONOS. This one looks familiar, right? The one on the left-hand side, that's MCO. And we have been adding, enhancing some of the functionalities to MCore. It's basically MCore structure. It's not exactly the same, but the structure is MCore structure. Some of the things that we've been adding, I think Guru mentioned earlier in his presentation, is that the configuration, device configuration. We call it as a underlay network automation. We automate the day 0 to make it as a plug and play. We also automate day 1 configuration. If you work with the switches, you might have noticed that not every switches, most switches actually, support different interfaces. There are different CLI, there are different REST API, different Yang model, they're all different. Right? So we've been working with multiple switch vendors and providing the drivers or southbound interfaces, as Guru mentioned earlier, to ONOS, such that we can configure a multi-vendor switches. And that allows our customers not to have a vendor lock-in in their switch hardware vendor. It's a completely disaggregate model. But we've been also challenging in that respect is that not many switch vendors, especially non-white box switch vendors, support OpenFlow. So that's one of the challenges that we've been dealing with, and one of the challenges that we've been working with the many various hardware vendors to overcome that. But for those that supports OpenFlow, what we have introduced is the OpenFlow certification, which is an automated confirmation test tool to verify ONOS and the switches can interoperate for OpenFlow support. We also added overlay network automation with service assurance. In addition, we added network slicing automation, and to tie them all up, we added 3D network visualization. Network slicing is another use case. Now, it can be part of the M4 or the 5G, but we put it as a separate use case. In 5G, the environment is that you need to support heterogeneous services, huge throughput services, ultra-low latency services, and massive connectivity services. With the end-to-end orchestration and dynamically controlled network management, we're providing the network slicing from RAN to core. So what did he do? What have we done to support network slicing in ONOS? We had to add additional functionality in the ONOS to support SLA, QoS, mobility. And also, we introduced a new box called Network Slice Manager. It's not part of the ONOS. It's actually it's orchestrator. It's outside of ONOS. That Network Slice Manager is the one that orchestrates slice end to end. And also the closed loop automation is becoming a big topic, right? And it is more relevant in a software-defined environment with SDN and NFV. And our support, even for the network slicing, what we have done is that we have SLAs and QoS monitoring and add that in with the closed loop control such that we can control or can manage or can meet SLA of each slice. We can control the traffic characteristics or the programming parameters of each services based on the real-time monitoring with the control loop. This is actually a screenshot from our Network Slice Manager product. And you can see the live demo outside of this, at the exhibition hall, right outside of this auditorium. The particular screen that you're seeing is the throughput management. This is 3 different slices. And we're monitoring in real time, and we're adding that into the closed loop control, and we're controlling it to meet the SLA at the flow level and at the service level. Okay, what have we been doing in ONOS code base? What are the changes that we're making? Right? So I highlighted some of the functionalities that we've been making changes to. And of course, this doesn't include all the base functionalities that Guru showed in his earlier presentation. I grouped them in 2 use cases. One is data center fabric control use case, which is that extends to the core, M core, and the other one is network slicing use case. And in terms of the drivers, we've been working with various switch vendors and data center switch vendors, and we had to introduce or adapt to their differences in their APIs and their management interfaces. So we added a fair amount of code base for the driver layer. And also, we had to modify some of the southbound interface layer. And in particular, we had to add the SSH layer and also the gateway control layer. And some of this code have been upstream to the ONOS community, but some has not been yet. There are actually a fair amount of code base that actually sits outside of the ONOS code base. However, our intent is to upstream them as quickly as possible. I think we need to work with the ONOS to see how we can upstream them quickly. But our intention is to upstream them by the end of 2018. We're not taking this MMVSDN or software-defined networking journey ourselves. We're taking them with our customer. And the dots listed here is the current commercial deployment and the trial deployment of Samsung products. The deployment use cases include LTE virtualization, virtualized LTE, virtualized core, virtualized RAN, and the new vertical market, such as private LTE, IoT, cellular IoT, NB-IoT, and also 5G virtualized core and virtualized RAN. Just not to confuse you, the commercial deployment has been in the virtualized network functions or NFV platform. Does not include the ONOS-based SDN controller as part of it. However, we do have trial customers deployment that includes the ONOS-based SDN controller as part of MMVSDN overall solution. I went too far. I asked the guru that my material is about 20 minutes long, so I asked him to cover, make his presentation a little longer. But I hope I gave you some brief on Samsung's activities with ONOS and with other open source communities. I hope I succeeded in that. But there are other opportunities. There are opportunities in particular this afternoon with the Samsung's technical session presentation. Please attend that. You can get a little bit more details on what we've been doing. Also, please stop by at the exhibition. The Samsung has booth there, and to take a look at our product and also see the live demo. Right. Thank you, everyone. Have a great event.
Thank you very much. Thank you. Great, so we're running, we have a few more minutes. If anyone has some questions, we have some microphones. We had planned, the keynote here was 20 minutes, and so we had a little, we just have a little bit of space, but if not, any questions? If not, of course, we'll have time during lunch later in the day for questions. Okay.
All right. Oh, thanks, Will.
Well, we have one quick question here. Okay, so actually we don't have a microphone. We will probably have to leave that question for after the keynote, so we can stay on schedule.
Sure.
Okay.
Sure.
Thank you. Thank you. Sorry about that. Okay. Thank you. Okay. Now we are going to start the ONOS roadmap session, and these awesome slides that you're going to see are we revised them just a little bit, so to make them even more awesome. So just wait maybe 30 seconds. During these 30 seconds, I just want to remind everyone that we will do a group photo in the lobby of the building, so just outside where you went through with the escalators. We are going to ask everyone at noon, as soon as the TST panel is over, to walk over to the lobby for a group photo. And this photo will be then published on the ONOS website. Now, for this next session, we're going to have ONOS a roadmap presentation, and so please join me in welcoming Thomas Wachuska, and Yen Chao from the Open Networking Foundation. Welcome.
Hi everybody, thanks for the patience. We're still getting the slides queued up. All right, excellent. So despite the title of the presentation that it says it's ONOS roadmap, we're also going to hijack it a little bit to give you a brief overview of the ONOS architecture and some of the rationale behind its general structure. Now, this is probably old news for most of you, but just in case we have some new attendees or people who are new and unfamiliar with ONOS, this should hopefully provide a base for getting familiar with ONOS. Next, click. I think this is the clicker. I presume so. Yes, it is. So, kind of three base architectural tenets of ONOS are its distributed core, which is required in order to make ONOS a platform for operating mission-critical networks, because we cannot afford any outage. We need to be able to scale, and we need to be able to perform in order to sustain the high demands of control operations that need to be able to be exerted over the network. It is also built around strong abstractions and information models in order to allow applications to be able to both control and configure the network, but also without becoming dependent on device specific. As you probably recall from previous keynote, Mr. Chong mentioned that devices are configured through CLIs, various different models, whether they're Yang or SNMP. So it's a forest out there of wild kingdom of devices, and clearly your applications should not become dependent on the nuances of those individual devices, and this is precisely why we built ONOS with strong abstractions in mind, to allow applications to be written without being codependent on the devices and their nuances. And lastly, ONOS is designed as an applications platform, because we understand that a priori we cannot know all the different applications that you want to, or different use cases that you want to use ONOS for, and so it's designed as an operating system, as a basis for developing additional software to suit your needs. So, as the basis for high-level scalability performance is provided by the ONOS distributed applications platform, which is in itself built on top of OSGI and Apache Karaf. But this is very generic in a sense that it is not tied to networking at all. As a matter of fact, it can be used as a distributed applications platform for anything, not necessarily just network control or network configuration. So what brings the network specifics into play is the ONOS networking core. And this is where the various abstractions are defined that make ONOS network specifics. Where we define notions of traffic selectors, the topology, traffic treatments, flow objectives, and so forth. Now, the ONOS core itself is designed to be as small as possible because we would rather add it through extension, through additions, rather than through subtraction. It's always easier to add stuff than it is to subtract stuff, because then you have to worry about dependencies and things like that. And so ONOS core is designed to be minimal, and the primary responsibility for extending it to fit various use cases needs falls onto ONOS applications. And ONOS applications, it's a little bit of an overloaded term. The term application here is really should be thought of as an extension, because it can fall into many different classes. It can be compiled models, it can be providers which absorb the differences between protocols, it can be drivers which absorb differences between devices, and it can be full-on traffic steering applications such as segment routing or VPLS or SDNIP and so forth. And so the ONOS applications are designed to blend in and look as much as the networking core as possible. Now, of course, not necessarily just the volume of the controller is extensible, but also so is its also external surface, which includes user interface, graphical user interface, REST API, gRPC, or other type protocols. Northbound protocols can be extended, of course, so same applies to the command line interface. The idea here is that when you write your application can blend in with the rest of the system so that it is indistinguishable from the core itself, structurally and aesthetically. Now, of course, the networking core itself is not monolithic, even though it often appears on the high-level diagrams as a single box. It's in fact comprised of multiple different subsystems. The point of this slide is not to go through the various subsystems, but rather to illustrate the fact that it is, the core itself is very, very modular. And it comprises of components which are network kind of agnostic, domain agnostic, as well as components which are very, very specific to the subject of network control and network configuration. So, there's just a little bit of a brief overview of some of the tenets. Now, just there's a brief history here before I hand it over to Yen to talk about roadmap. ONOS, just as a reminder, ONOS released in December 2014, and when we released, it was just this core architecture that I just outlined that came with 4 different applications and support for one southbound plugin, which of course was OpenFlow at the time. But now, 3 years later, we have a platform which has many features and many applications on it. As Guru mentioned, we have now over 125 different apps, which includes various outbound plugins, models, drivers, and so forth. And these clearly provide many different capabilities, and also we offer as part of the core many different distributed primitives for even greater extensibility of the core itself. Now, of course, we did not add this all at once. This was added over a number of releases, and the whole idea here is to show incremental and forward and steady progress, and allow the community to participate in this, but also at the same time to maintain coherence of the architecture and stability and quality of the platform and quality of the code. And so at this point in time, I would like to hand it over to Yen to talk a little bit more about the releases and some of the roadmap items. Ready? Thanks, Yen.
Okay. So ONOS is released in quarterly releases, which means every 3 months we come out with a new release. It started off with Avocet, which was released in December of 2014. And as Thomas has noted, the release was very focused on making sure that the architecture is solid, that the core is modular and is protocol independent. Within the next 3 months, there was a Blackbird release, and the focus on this was to make sure that the performance was improved, it was scaled out and robust. And so what you'll see is for each 3 months, we have additional releases. For example, Cardinal focused around new use cases, Drake, platform enhancements, IMU with Chord. So as many of you are familiar with Chord on our use cases, ONOS is used very prevalently there to enable use cases like our core, being able to deploy AAA application, DHCP. In March of 2016, we released Falcon, which is the 1.5 release. And here we added dynamic clustering, additional Yang compiler support, and new outbound. So GoldenEye came in 3 months later with some core enhancements and some GUI scaling. There's Hummingbird, Ibis, Junko. We'll catch up to this year. So in Kingfisher, which released in May of 2015, we added Yang tool support, so there's been a lot of interest in dynamic configuration. So what you'll see there is a lot of enhancements to support dynamic configuration and be able to support Yang compilation. In Loon, which we've released very recently, what you'll see there is full Yang auto support, as well as the Yang compiler, which allows you to be able to dynamically load a Yang model and have it be compiled on the run. The other significant changes would be support for open config model and deprecation of YMS, so that we're fully utilizing the new dynamic configuration system. And other significant changes there are the core HA enhancements. So there's been a lot of changes in the core and HA space to make it more stable, so that you can run HA more fully. Some really interesting changes that are coming up, and an initial version was released was P4 runtime. So with P4, you're able to dynamically load a new pipeline onto a device, allowing you to support many new use cases. And so recently, we've added support for a control protocol called P4 runtime that the P4 Language Consortium is in the process of defining as part of their new API working group. Another change we're adding is ISSU. As Guru had noted, we want to get towards deployments, which means we need to make sure that the platform is ready to support use cases like that. In-service software upgrade is definitely a significant step towards that, and we've made some changes in Loon to provide some initial support for that, especially around portable serialization. In Magpie, which is the release that will be coming up in the November timeframe, we're looking at a lot more changes in ISSU to provide a full protocol support for that, support for the dynamic config store, be able to provide additional support for Yang, so updates to version 1.1, and a device synchronizer in that space that would allow you to essentially realize what you want in terms of configurations on the device. Roadmap. This is a pretty big picture with lots and lots of information. So what you'll see here is in the Loon release, we actually listed out all the things that we provided. So what you'll see in core are the enhancements to the HA framework to make it more stable. And then you'll see in dynamic config the changes we've noted. The open config model support, live Yang compiler. With ISSU, the focus was around making that system ready. So the focus was around portable cryo serialization, so that we can provide forwards and backwards compatibility. We need to make sure that as we deploy upgrades to this system, we're able to communicate and have nodes beyond different versions and be able to talk back and forth and work through consensus. With P4, we've added P4 framework, P4 runtime, which allows you to be able to communicate with the device and be able to update table entries. The focus of our release is around BMV2, which is the behavioral model switch that supports P4. gRPC updates, virtualization, GUI. A big step here was around localization. So what you can do is we've added some internationalization support. You can go into the topology view and get content in Chinese. And with QA, we've provided or published a business performance paper, so you can see what our latest performance numbers are. And we've maintained those really well. So, with Magpie, which is already released in the November timeframe, you'll see that there is a lot of work planned. So with dynamic configuration, there is a lot of work planned around being able to support per device view into the configuration. So on a per device, you should be able to get the config and set that. We're looking at the configuration synchronizer, Yang 1.1. With ISSU, we're really taking that to the next step in terms of protocol support. So Jordan, our distributed architect, recently provided a proposal around a protocol that would allow us to be very robust in terms of our ability to do rolling upgrades in the system. What you'll see there is we're going to focus on the core stores. And so we'll focus on making sure that those can be upgraded. As we look at the next release, we're going to move that up to the next level in terms of applications and be able to upgrade those. With the core, what we're looking at is more focus around distribution, right? So we've got a lot of good distributed support in ONOS that we're actually moving out to Atomic so that it can better benefit the rest of the community. And then P4, additional support there around P4 runtime, be able to support groups, device mastership, GNMI support. So what you'll want to do is be able to provide control support for your devices, but also config. And we're looking at DNMI for that, as well as support for open config at that level. gRPC support, GUI, topology 2, and of course additional localization to make sure that the rest of our community can consume this. QA, a performance paper, a technical version of that, and then we're looking at some enhancements to build-in infrastructure as well as some incubation around P4. We definitely see growth in this area. So what you'll see that we want to explore is VNF offloading to the hardware, be able to better make use of the availability of what's in the switches and be able to offload some of the functionality there. We want to get better telemetry, so we're looking at GNMI as well as INT, which is in-band telemetry, and be able to get better metrics so that administrators can make more intelligent decisions about what they want to do with their network. The P4 fabric, so we want to extend P4 into the fabric so that you can run a fabric that supports both traditional switches as well as P4 enabled switches. ONOS provides great abstraction layers so that your existing applications can run on both types of devices, as well as looking at dynamic program loading. And then we're looking at additional support around virtualization. In N, which is a bit further out, I'll note some quick highlights. With dynamic config, sharding, and optimization, with ISSU, we want to extend ISSU to the next level and be able to support applications and their custom logic and be able to upgrade those. With P4, rolling the incubation work out to deployment, essentially. gRPC support, and we would be able to search and filter, as well as some additional support around virtualization. So we'll go into these all in a bit more detail in the next few items. So you'll see that these are our near-term, highest priority items. We want to focus on making sure that we have a great dynamic configuration system deployed. So this will be some incremental work to kind of finish that. And then with in-service software upgrade, this is the release where we're really focused on making sure protocol is in place so that you can upgrade your system. P4 integration, P4 runtime, and GNMI gRPC API, scalability, some enhancements around build and release to support our community in terms of their development effort, virtualization, code basis aggregation to provide more independence to the community in terms of the projects that they're proposing, and federation so that we can better scale out the system. Okay, I'll hand this off to Thomas to cover dynamic configuration since he's been working most closely with that.
Sure, I can quickly do that. This is really not, this is just to describe the effort for the dynamic configuration. This is not necessarily the inventory of work that's being planned ahead. But just in general, I should perhaps correct a little bit of a misconception. It is true that ONOS was behind in support of the Yang toolchain. However, it is not true that we were behind on device configuration because, as a matter of fact, we introduced the device driver subsystem in the Blackbird release, which was our second release, which meant that applications as of Cardinal release could start engaging in doing device configurations. Device configurations using the driver mechanism, which provides strong abstractions. And this is something that we still want to maintain going forward. But as part of the sort of the dynamic configuration effort, what we are trying to do is provide a generic core central subsystem in which the device configuration can be tracked on behalf of all devices in the system and on behalf of various services that operators want to deploy in their system. And this will allow the information that is tracked in here will be tracked in one central subsystem rather than what is normally happening in ONOS, where each subsystem has its own separate store where it can distribute the information in accordance with its needs. Now, the approach that ONOS currently uses in this store per subsystem, it allows for much higher performance, because you can take advantage of knowing a priori what the structures look like. But at the same time, it does bring a little bit more higher point of entrance for applications which need to, or application writers, because they need to author their own stores. So with the dynamic configuration subsystem, there's one store which allows the various service and device configurations to be ingested without really writing almost any code a priori. Of course, this is all required. This is all predicated on having adequate tool chain, which is a Yang compiler and Yang runtime. Yang compiler is an entity that's capable of taking the raw Yang files and be able to transcribe them effectively into information model that can be digested and manipulated at runtime for both validation and encoding, decoding purposes. It of course requires having a place to store all of this information, and that's the dynamic configuration store service. And this is, again, as with all subsystems, this is something that needs to support high availability, scalability, and performance, and thus it needs to be distributed across the cluster. And finally, one final piece of the subsystem is ability to be able to actually engage in interacting with outside entities, whether it's orchestrators that lie to the north or whether it's the network elements which lie to the south. And this is done usually through adapters, protocol-specific adapters such as netconf or resconf. And these are basically either southbound or northbound adapters which operate either in client or server mode, respectively. And you'd use those specific protocols to be able to then exchange information, which is usually structured in XML or JSON. In case of GNMI, it's actually Google protobufs. Those sort of encodings are used on those external boundaries. And so this is kind of a high-level outline of the dynamic configuration brigade, what they're working on. The specific items for the Magpie release or for the previous Zoom release was something that the Yen has already mentioned. So I just wanted to provide these high-level overflight over kind of the big picture for the dynamic configuration brigade.
Okay. So what you'll see in terms of the pattern for the next few slides is really kind of the overview of what we're planning to do for each of the features that will be coming out in the upcoming releases. For the in-depth details, you'll want to attend the sessions that will be available tomorrow, where we're going to go more in-depth into, for example, in-service software upgrade. We'll be going into the proposed protocol that we're looking at for the next release. So with in-service software upgrade, what we want to be able to do is provide a system where you have multiple nodes in your cluster. And we do not want to take down all of the nodes to be able to upgrade it. So the intent would be to bring down each individual node, be able to upgrade it and not impact the services in your network. But what that implies is you're going to have a set of nodes in the network that will be running different versions of the software. So how are we going to support rolling that out? So we've done some initial work in Loon to be able to support portable serialization. This would allow us to be able to go forward, go back, be able to remove elements. We're still extending that out. There are some limitations, and I'll cover those in more detail tomorrow. So, please attend the session then. Other things we're looking at is there's the new protocol, which will allow us to be able to look at a multi-phase commit process that would allow us to make sure that if there are issues, we can roll back, which is very critical as we're looking at moving to new firmware. So noted, we need portable serialization to support this. P4. Okay, so with the advent of all the programmable switches and ASICs that are coming out, we see P4 is pretty critical for us to be able to get to that next level with SDN. To be able to provide more programmability in the network and to be able to allow you to be able to customize that network more fully. So what you'll see is the work that we've done. We're going to focus on making sure that programmable pipelines can be pushed down onto these devices. We're looking at a unified control and config mechanism, and this is actually based on the work that the P4 Language Consortium is doing. They're starting a new API working group, And what they're proposing is the use of P4 runtime as the control mechanism and GNMI using gRPC as the mechanism to allow you to do configurations on your network. So this is where it gets interesting because traditionally with OpenFlow, for example, you can program your tables and then you can get information like port status, right? Well, here with P4 runtime and GNMI, you're going to see actually an interesting change where you're going to be able to push down your programs via P4 runtime, but you then have to use GNMI to do configuration and basic things like your port status. And so it's an interesting way they're pulling that apart. But of course, this allows both protocols being over gRPC to be much more efficient. We're looking at supporting for both pipeline agnostic and aware applications. As Thomas had noted, there's great abstraction, which means we're able to bring in a lot of these, the support for this on the southbound, which allows abstraction in the northbound to allow you to continue running your applications, to be able to do reactive forwarding, using the existing applications that are there, and then just using drivers that you can put in to be able to support additional devices, whether it's OpenFlow or P4 devices. We're looking at additional things around telemetry. We're hearing that that is critical for providing visibility into the network. GNMI allows support for us through streaming telemetry. You can do it with P4 runtime through INTs. So this provides you with band telemetry. You can define custom headers that allows you to pull information and then have it come out as part of your traffic. And then of course a P4 fabric. This would allow us to be able to deploy both OpenFlow as well as P4 devices and be able to support them as part of your fabric. gRPC. gRPC is more performant. It allows us to provide more fine-grained access to components within the system. So if you want to be able to deploy applications that are off of the platform, this would provide you with a great opportunity to be able to leverage the functionality that ONOS provides in terms of its visibility into the network, but having a more performant API that allows you to access that information and be able to provide applications in the language of your choice, whether it's Go or Python. It enables you to be able to look at what we have in much more granularity. Okay, UI scalability. Thomas was going to go into this in more detail.
So the UI scalability in here primarily refers to the scalability of the topology view and an ONOS user interface. In the past, or actually as a matter of fact even today, the classical topology view provides a flat view of the network, which means it shows you everything, all the information that ONOS currently knows about the network in terms of the devices, links, hosts, and various details behind them. But that scales, even though the user interface technology itself is capable of displaying thousands and thousands of devices, the human is actually the weak link here, and the human can't really digest it really easily when it's presented in a single flat view. Looking at a user interface which is speckled with thousands of dots doesn't really provide you with a lot of data, but not with enough information. And so the idea behind the UI scalability is the topology scalability is to actually allow the topology view to be segmented into regions and to be able to zoom in and zoom out of those regions, so that, for example, you can be looking at a high-level overview of the network on a continent, and then you can zoom into a country, into a metro region, down into the center, data center, and potentially down to a specific rack view. And then you can seamlessly zoom in and zoom out across all of these layers. And this allows the person, the operator, to be able to view the information in much more digestible form. And so that's the rationale behind adding some of these UI scalability features. Now, we currently support both the topology the original topology view as well as the new topology view. And the reason for supporting both today is because the new topology view has not caught up in terms of all of the functionality with the old one, in terms of supporting overlays, supporting some of the different the user interface features. But it is there for people to start working with and experimenting. And it has been used in a number of different demonstrations in the past few conferences. So the work on this user interface will still continue into at least into the M release, if not a little bit into the N release as well. So some of the more details behind this is to also add a little bit of some smoother user interactions in terms of being able to customize the different layouts rather than be able to support just the physical geographical layout, which you will often see in demonstrations. The idea is to be able to also support various logical layouts, for example, spine leaf. So you can be able to take the same topology and view it both as a logical spine leaf fabric as well as a physical layout of switches in a data center room or even in a rack. And so the same topology can be viewed in two different ways. Also, be able to support smoother scaling with basically icons that will zoom only so much and then they'll stop scaling as well, or so little and then they'll stop scaling down. We've also revised some of the UI glyphs for various map entities and various buttons to be more visually consistent, and some of that work is still going on. Some of the roadmap items that are further down is to be able to support global search from the user interface. We will provide a search bar and a mask, and you'll be able to type search terms there, and you'll be presented with the results that will allow you to view devices, links, intents, or whatever whatever entity ONOS knows about which matches the search criteria. That's just at a high level some of the user interface enhancements that are planned.
Okay, some additional work that was done was around virtualization. So with virtualization, what you can do is you can essentially create virtual networks, tenant-based virtual networks, and be able to support programmability. So what is different from other virtualization solutions is that what you can do is define a virtual network. You can be able to push flow rules down into it like a normal network. What you're going to see with the virtualization is we're looking at some additional enhancements. So for example, one of the things that we would support is an OF agent. So with the OF agent, what you're able to do is you're able to treat ONOS and its virtual networks as an open flow agent, and on top of it you can have another controller or other controllers and then be able to treat those networks as just open flow networks and be able to program those. We're looking at some additional functionality that are coming up that would allow you to do a gateway and provide internet connectivity as part of your virtual networks, as well as some additional enhancements there. But the team is still working through getting the rest of the OF agent functionality in place. So recently there was support for LLDP as part of what they're adding there, as well as making sure that it's fully fleshed out in terms of the functionality or the programmable functionality that is currently on the ONOS platform. Code basis aggregation. So as you've heard from Samsung, they're looking at contributing a lot of changes that they've been working on to the system. Code-based disaggregation is a way that we can provide independence to projects that are being proposed, so that we can start pulling apart the components within the code base and be able to allow different components to live in their own separate repos. What this ensures is that, as we're rolling out these repos, there can be less centralized reviews of things. This allows the projects to progress at their own pace. Right? So what you can do is Samsung can propose a series of projects. They can go in their repo. You can have your own module owners that are reviewing them independently with, of course, help from the core team. And so what we're doing is we're looking at this in conjunction with some of the build and package work that we're doing to provide infrastructure that would allow this to happen. We're also looking at this in conjunction with other things like, for example, disaggregation of the components within the code base to provide more independent deployment of those. Cluster federation. So we definitely see scale out as being critical to deployment, similar to being able to do IS-issue. So with cluster federation, what we want to be able to do is have scale out in terms of hierarchical as well as peer-to-peer, right? So what we want to be able to do is build mechanisms that would allow different components in the cluster to be able to communicate with other clusters so that they're able to exchange information, but in a less granular perspective so that they're not all necessarily holding the same state. So we have not started too much work here. There was work on peer-to-peer by Giant, and so this is definitely going to be one of the more future items that we're looking at. So you see a lot of things being presented, and I guess the big question is, how are we going to be able to do all this work? What you saw in Magpie was we had a lot of things on our roadmap. So one of the ways that we're able to do this is we're using brigades. If you look at all the work that we're currently doing, we've got an ISSU brigade that will be starting up soon that we'll be looking for help on. So if you have any sort of knowledge in terms of distributed systems, please come and volunteer and help out there. But what you're seeing is we're leveraging the community in terms of what you can do to be able to help us deliver what we're trying to do. And this is why we're sharing our roadmap, is so that you're aware of what is coming up so that you can leverage it or fully contribute to it. So the brigades that we have in place, we've got dynamic configuration. So a lot of the work that Thomas has been talking about in terms of dynamic configuration, those have been contributed by our community. The virtualization work, Unisoon from PostTech has been instrumental in providing that GUI. We have had great contributions from the community to be able to provide better look and feel in our UI, as well as better tooling so that you can get code coverage. gRPC, we have Jen who is graciously leading that and helping us to be able to get the functionality that is currently in ONOS, be able to provide them as protobuf definitions, be able to provide them as services that external applications can leverage to be able to communicate with the devices. Teaching Brigade. The Teaching Brigade has done a lot of work. What you're going to see is the tutorials that are being provided are being contributed by the Teaching Brigade. So please attend those and learn a lot more about ONOS from that. Build and release, we want to make sure that we enable you as the community to develop and contribute to the code base. So we're looking at tooling to make that happen. Northbound Brigade, be able to provide more intent functionality and security and analysis. As we look more fully at deployment, we want to make sure that the system is performant, the system is secure. What you'll see in our releases is that we've actually been handling and getting, this team has been looking at it, submitting security defects, and we've been handling those in a very timely manner. So you'll see updated security advisories on issues that have been recently found. But what this brigade is working on is they're working on the analysis and providing a paper that will be released shortly after ONOS build so that you can better understand the current state of the ONOS system. And then of course a major new initiative that we're working on is P4. Right? With the P4 work that we're doing, we're making lots of changes to the system to be able to provide you with support to better program your network. So you'll see support for P4 runtime, but as part of that, significant changes in the system so that you can have gRPC support, and then this way we can leverage it for GNMI as that comes up in the next release. So there is a lot of new work, there's lots of exploratory work that we want to do in this space, so please contribute and feel free to talk to any of the ONOS team members and ONF team members that are here this week, if you're interested, especially our community managers, David and William. And they'll get you connected with our brigade leads. So for more information, we have a wiki. We have on the wiki also the roadmap in detail and information on all the brigades. The information for the brigades will contain contact information for the brigades, brigade leads. We make sure that there's Slack channels, Google groups, and so you're welcome to send messages out on that and reach out and connect with the teams. We thank the ONOS community for your contributions and your future contributions. So please help. I think that was all we got.
That was it. Great.
Okay.
All right. Thank you so much, Thomas and Yen. Thank you so much. So the good news is that we have a few minutes until our next panel discussion. So let's take advantage of this time to open up the floor for questions. I'm sure you have some questions about the ONOS roadmap. So now is your opportunity. We have some microphones there in the middle of the row of the auditorium, so you can stand and just ask your question. Or we have mobile microphones also. So, any questions? And maybe you can ask your question in Korean. And I will not translate. Maybe someone can also translate for Thomas and Yen. Don't be shy. I know you have questions. Okay, we're going to wait a few seconds. Okay, I know you're saving your questions for the panel discussion. Okay, so thank you once again, Thomas and Yen. Please give them a little warm welcome, and then we will now set up the TST panel. So the ONOS technical steering team will be coming on stage. So we'll need about 1 or 2 minutes to put the chairs. And while we set up the chairs, one quick reminder for just logistics. We would like to have, I mentioned this earlier, we would like to have a group photo. So this is our tradition at the Open Networking Foundation. We want to have a big group photo to really strengthen this idea of community around the world. And so we'll be doing the group photo in the lobby right after the TST panel. So it's going to take about 5-10 minutes to get everyone there in the lobby floor. And Andrea and Brian will take photos, and then that will take a few minutes. And then after that, everyone can go and have lunch in the cafeteria, which is in the basement. And we really recommend you to go to the cafeteria at around 12:15, 12:20 to avoid the crowds. And then, of course, we have the SDN Science Fair. Lots of awesome projects and demos that you can see at the Science Fair. And of course, we have posters. So that's going to be right after lunch until 2 p.m. And then after 2 p.m. we start with the tracks, the ONOS Basics track and the Community Showcase track. Okay, so I think we're ready for the TST panel. I will welcome our moderator, Sango Shin, excuse me. And then we have our panelists, Thomas, Jono, Utah, and Brian. Please, guys, come on stage and we can start the panel discussion. Now, one very important point, this is very interactive, so Sango will be asking questions to the panelists, a set of questions, and then we'll open it up to the audience. So really, we'll have microphones. We can run up and down the stairs, or we can give you the microphone and you can ask your questions to the panel. Okay, welcome.
Welcome to the TST panel session. I'm Sang Shin from SKT. Okay, so it's really good time to ask any questions about ONOS and any other SDN. So please prepare any questions. So we have some microphone over there. So go. Okay, so let's start with some introduction. So can you please introduce a little bit by yourself from maybe John?
Yeah. Okay, my name is Jonathan Hart. I'm a developer at ONF. I've been working there for almost 5 years now, ON.Lab and now ONF. And I've been working on the ONOS project for about the first 3 years of that time, since before it was open source, and now I'm focused mainly on the cord project, specifically residential cord.
But I would like to add that we actually see a lot of contributions from John on the ONOS side. Even though they may come in under the cord umbrella, they're still extremely valuable. You guys met me, I'm Thomas Wachuska, I'm the architect for ONOS. Still try to contribute, even though it's less and less these days because a lot of the time is spent doing code reviews and things like that. I've been working for ONF for the past 3 years now.
I'm Yuta Huge from NSC. I've been working with ONOS from something like 2015 or something, and basically working mostly in the areas related to the packet optical and transport side of things.
Hi, I'm Brian O'Connor. Was at ON.Lab starting in 2013. So I've been working there on Mininet. Now at the ONF, been with ONOS probably around the same amount of time as Jono, around Utah. So yeah, been kind of all over the code base. And a lot of the work I think that we've been doing is trying to make sure that the community is successful lately. So.
Okay, thank you for your introduction. All right, now we have plenty of time, fortunately. And how many people attended to the last ONOS build? Right, a few of them. Okay, that's good. All right, so this is a TST panel session. I guess everybody knows what is a TST and what they're doing. But maybe Thomas can introduce a little bit more detail about what is the role of the TST on ONOS.
Sure. So the primary role of TST is to kind of maintain the cohesion of the ONOS architecture by providing providing code reviews and providing design reviews and in general providing kind of consulting services for when new applications or new functionality is being added to ONOS, just to make sure that it adheres to some of the design principles which I've outlined earlier, and to make sure that the code base remains clean and sturdy. That's the primary sort of purpose for the TST.
All right, thank you. All right, so before you ask some questions, let me ask some common questions to all TST members. So please be prepared for your questions. All right, so this is very common questions. So we had first ONOS build last year. So after that we had 1 year has passed. So what do you think was the kind of big achievement, what kind of big accomplishment? So after the last ONOS build?
Yeah, so I think for me it's really looking at the general sort of maturity of the platform, right? I think things are generally progressing in a very good way, and we can see the software is getting much more stable and mature, and this is kind of validated by the fact that we're seeing more and more operators and companies interested in deployments, right? So for me, the deployments are the best validation that the work that we're doing is relevant and is really being useful to companies in the industry. And so it's really great to hear about more and more deployments and to see how the platform is really maturing towards those.
For me, it's kind of could be summarized into 2 different points. One of them is similar to what John mentioned, is the deployments. One of them is probably kind of a highlight which we've learned recently, is that an Austrian company based in Vienna actually used ONOS as a platform to develop a solution for managing air traffic network, which is not only, it's safety critical, it's not just a mission critical, it's safety critical network. And the fact that they were able to achieve this really almost without any of our knowledge, we did not learn about this until the product was put in place. And they've contacted us. So that's, to me, that's a testament that the software is reasonably easy to use, and as John mentioned, it's getting mature and robust enough to start to be used in such situations. And second point is the involvement of the community. We're seeing much more diverse involvement from the community members, and we're seeing this sort of materialized in the notion of the brigades, which you will probably hear echoed throughout this conference. I think that's a very powerful mechanism for getting a community involved and focused on working on kind of in a cohesive fashion on some of the important features.
Maybe I would say something around, we are starting to see some of the seed of dealing with analytics, that kind of things. Back then we did sort of have control plane performance metrics in place, but since then we now have, at least in the optical layer, we have now visibility into the power level things, which eventually can come back into control loops to optimize the network. And now we have microsemi starting to contribute, providing metrics about OM performance monitoring. So once we have those performance metrics and a control in place, we will finally have a control loop to build more optimized networks. So that will be interesting moving forward.
Cool. To sort of add to what's been said, I think platform maturity is extremely important, but from a developer perspective, community maturity is also important. And I think since the last ONOS build, we've added a significant number of module owners. We've seen a dramatic increase in the number of brigades that we support. From an infrastructure perspective, we're currently in the process of moving our infrastructure, which has been sort of ad hocly managed by more or less the core team, to the Linux Foundation, who's going to provide 24/7 support and scale for the infrastructure. Code-based disaggregation, we haven't necessarily made a tremendous amount of progress yet from a practical perspective, but from a theory perspective, we've made the commitments. And all of these things help make developers more productive. They help make the community more inviting. They help make the experience more stable for people coming in. The tutorials from the teaching brigade also help ease the ramp coming in for new developers. And as a result, I think we've probably seen 100 or more new developers on the project, many of whom have been able to get to where they are without much help from individuals, or rather the core team per se. I think the other thing which we've done since last ONOS build is been around looking at the future. We've taken dynamic configuration and open config from basically idea to something that's working with our dynamic config and Yang tools. We've introduced support for P4 runtime and P4. Previously, we've done some demos using more or less proprietary Thrift API. And we're still looking at making sure that ONOS is a platform that is not just ready for your networks today, but ready for the networks of the future.
Thank you, Yeah, as they said, like for the last 1 year, ONOS has been growing like in terms of community and performance, or some technical things. All right, so now it's time to take some questions. So if you have any questions to technical steering team, then please line up and ask any questions. Okay?
Just one question.
Oh, sure, yeah. Great. Okay, yeah, go ahead.
So, I see that you are trying
I'm sorry, can you please share your name and
okay.
information?
I am Michele Santuari, I work in CreateNet, and I am also an ONOS ambassador. So I see that you are trying to disaggregate the code, but my question is, do you think that it's possible to disaggregate the service inside ONOS? So that you could have some service that are very close to specific equipment, and also, for example, I can think, I have like layer 3 device, and I would like to have some specific functionality close to my device, and if I lose the connection with all the other services around my cloud, I will still be able to manage such device because I have some basic component very close to the device itself. I don't know if it's clear, my question, or should I rephrase it?
So maybe I can try to summarize. So when we talk about code-based disaggregation, currently what we're talking about is the fact that most of the ONOS drivers, applications, and core services are all located in the same Git repository, where the quality of code is fairly high, the barrier to entry for new developers is a bit arduous, but where we're trying to go is we're trying to move to a more disaggregated model from a repository perspective. The question you're asking is more about, we have this notion of a tightly coupled control cluster. Can we break up the cluster either through federation mechanisms or through some sort of hierarchy such that you can have different ONOS clusters or even ONOS instances that are separate from the main cluster? And I think we've seen a few different efforts. There's one effort around using gRPC for some remote intent processing for the eCord case. So I think the eCord example is probably the best one, and maybe Ito wants to talk more about that.
Yes. So yeah, in the eCode case is a little bit unique. Or I guess we haven't been to the core use case in the first place, so it's kind of hard to articulate what the difference about eCode is. That eCode need to orchestrate multiple sites, so we definitely need some form of federation, but we don't want to expose the whole detail of each site into the global orchestration to make the decision. So we will need to provide some level of abstraction up above, and that is the kind of thing that eCode is currently working on. Now, it's not really generalized application yet, but Francesco in the audience there has recently built an application that will give you the big switch view of a central office and populate that information up above so that the overarching controller can do the global path computation, stitching multiple central offices together, controlling them one. That's the kind of things we are exploring right now.
Okay. Yeah. And just to approach it from a slightly different direction, there's also this notion of many sort of applications or use cases, things are proactively provisioned for the most part, but then there's this sort of reactive handling that needs to be happening, right? For one good example of this is answering ARP requests, and often the controller is involved with the packets coming up to the controller is figuring out what's the right answer to give back to the host and sending it back. But there's really no reason why this can't be pushed down to the device itself, right? Because it's always the same thing. If an ARP request for a given target generally has the same answer. We've talked about this notion of being able to push some of this reactive processing down to the device and have that handle it by itself without needing the controller to be involved. And what that means is that you actually have much better sort of resiliency, right? If you lose connection to your control cluster entirely, then the devices can still handle things like ARP requests or DHCP requests and things like that. So,
thank you very much.
Okay, thank you for your questions, answers. Anybody, if you prefer Korean, then please use Korean. I'm so good at speaking Korean, so. Okay, so probably, Then, okay, just in case I have prepared some more questions to you guys. Okay, so please be prepared here for questions during this next question. Okay, so let me ask some next common questions. So, you guys have been involving building ONOS for 4 years, right? So, what was kind of the biggest hurdle, or what was kind of biggest challenge so far?
I think one of the hardest parts of ONOS is really the distributed core, right? I mean, that's some of the most hardest challenges in all of computer science, right? So, getting those questions right and figuring out, what are the right kind of storage mechanisms, what kind of state needs to be stored in different kind of storage mechanisms, what kind of consistency you need. I think figuring out those kind of questions has been one of the central kind of architectural problems within the entire ONOS project. So, yeah.
I mean, I think another big area, especially when we started, has been hardware support. Software developers, we like to have emulators and models for doing development. We've had Mininet for years. We've continued to have a wide variety of really high quality software switches, which have enabled us to do a tremendous amount of development and make a tremendous amount of progress. But one of the things that we're just starting to see now is this general availability of high quality switches. And so I would say that that probably has been more or less, it's not so much an architectural hurdle, but more or less a reality that's prevented us from deployment prior to maybe 1 year ago. So yeah, I would say that for me has been a consistent.
Right. Thanks. From my viewpoint, if I can add to it, I guess it's been striking the balance between the simplicity of the abstractions without oversimplifying them too much, because clearly if you once you define the abstractions, they're somewhat fixed, because if you mutate them too much, then you don't have any backwards compatibility. So once you fix them, then you're kind of stuck at being able to do just those sorts of things. Whereas you know, a lot of devices expose a lot of unique features, and so the heterogeneity of the devices, balancing the heterogeneity of devices with homogeneity of the APIs, that's been a little bit of a challenge. You know, clearly time will tell how well we've done. So far, so good, but time will tell.
Right. Okay. So, any questions? Great. Yeah. Go ahead. Yeah. Thanks. And please start with your name and organization.
Hello. I'm Afaq Mohammed. I'm a postdoctoral researcher at Jeju National University. We are actually working on MCOD end-to-end slicing. I'm not sure whether this question is related to this session or not, but we were wondering if there is any open source or generalized app for slicing the RAN part through like ONOS and OpenFlow protocol.
So just to repeat, just to make sure I understand the question. Yeah. So the question is there any open source
app, like slicing app?
Slicing the RAN, right?
Yes, yes.
I honestly don't know. So with ONOS, we talked about virtualization brigade, so it could be conceived clearly that the ONOS virtualization mechanism could be used for this purpose, but actually upon closer look, when we've had discussions with MCOD architect like Oz, we sort of realized that even though the virtualization does provide reasonably generic mechanism for virtualization, it really does not meet some of the stringent requirements that MCOD has with respect to be able to really carve out and reserve certain resource availability of that virtual network in the underlay. And so, we're still trying to figure out what is the best mechanism. Right now, the thought is that the best mechanism for providing the slicing is actually going to be met by the trellis application. And for that, you would have to probably get more details from Sorov, who's kind of the principal on a trellis application. But in terms of external open source mechanisms, I honestly don't know of any. This is the closest within the realm of ONOS code base that I can give you an answer for.
Thank you very much.
Actually, I was working on MCOD a little bit, so I can answer. Maybe it might be best answer or not. But actually, MCOD is a little bit different from the other area of like R code and E code, because MCOD is kind of for a mobile telco operator. And then MCOD requires a lot of kind of like a VNF, like EPC or MMVS or something. Those are not really easy, like simple VNFs. So also there are many like telco vendors for commercialization. So it's really difficult to to make the real network slicing. We need to have kind of like a VPC, VME, or VIMS or something. But actually, it's really difficult to open such a source code. I'm not sure. Maybe if, like, I know that Redis is trying to do something, but maybe if it's open, it's too complicated to see or to maintain. So probably a little bit. It will take a little bit more time to see some open source of real, MCOD use cases.
Thank you very much.
You're welcome. All right. So, any next questions? Okay, great.
Hi, my name is Kanta Yamamoto. I work for Fujitsu. I have two questions. One is, well, which is created in VMs or containers. I'm not sure which it is, but the throughput would be poor. It's my personal impression. Is there any activities you think you need for getting more performance? The second question is, okay, but just one question.
So just a clarification before you leave, right? We may need more data. So throughput of what? Is it flow operations or intent operations or?
Some instance running inside the servers, or so. My understanding is some controllers on some.
It's like ODL or something. So are you talking about like performance comparison between like ODL or you or something and ONOS?
No. Speaking of the residential code, BCP is implemented in the container, but I'm not sure the performance throughput of its instance is good enough for real service.
So there's several techniques you can use to kind of get the best kind of I/O performance when you're going from the network through to the CPU-based functions. One of the most common ones is Intel's DPDK, right, which gives you very, very fast line rate ability to move data in and out of the network card. So there's been a lot of work recently, specifically in our code, about using DPDK with the VCP to really improve the performance there. And then I guess looking forward, there's also these ideas of being able to move some of that functionality into the hardware itself, right? As we get more and more capable hardware and more programmability of that hardware through things like P4, then it may become possible to actually take these functions that right now we're running as containers on x86 and move them into this programmable hardware. So you really do have a fast path entirely in the network.
So some functions going to move to the hardware like in P4. So I found some activities that homing gateway functions going to move to the switch, P4 switch, right? And so I wonder that some functions which need throughput going to the hardware, not in the server side. Is it what you're going to take for getting throughput?
So I guess you mean kind of some NIC offloading or something like, right? Hardware offloading of OBS function, right?
Yeah.
Okay, so actually I've been working on also some data plane acceleration. So we've been looking at some DPDK, as John said. Also there are some smart NIC that offloads the entire OBS function. Also recently, like Intel has announced kind of a Xeon and FPGA board, right? Also we are doing some kind of a POC with them. But still, I think it's still early stage. Then I'm not really sure if we can really utilize it. But of course, the vendor says that it's already commercialized. But still, I can. My feeling is that still it's far from some commercialization. In terms, not because of the hardware, it's because of software. So I think we need some more like progress on the driver and software or something. Yeah. And I know that the Samsung guys has kind of an expert of DPDK, so if you have any good, proper answer, if you can answer, and then please just raise your hand and you can answer to that question. Any? Right, so still we have a plenty of time. So do you have any question? Nope? Okay, great. David. Thank you, finally.
Hello, I'm David from the ON.Lab. So I have two questions, and the first maybe, Senko, you can answer, but Guru earlier talked about the great contributions the Korean community has made, so I'm just curious to hear from maybe you or other people from the community, how how did that community come together, and you know, what was it that helped form, you know, the community here? Because I'm curious, because we want to replicate the great work the Korean community is doing in other parts of the world. Like, how do we build a community like that somewhere else? So I'd be really interested to hear about how it all came together. And then for the TST, you know, you just went through the roadmap and there was a lot of stuff there. Like, if you had just one or two things that are top of mind, what would you love to see the Korean community help with most? Like, of everything in the roadmap, like, what on there is the most, you know, pressing?
Okay, so community. Okay, so William, do you have something to say? Or?
That's for you.
Okay, it's for me, I see. Yeah, okay, so yeah, actually in Korea, Jiang Lee, he's kind of a leader of the ONOS called Korean developer community. So we have built, so we have kind of, we started our ONOS code community from last year. So we are like doing like bi-monthly workshop. So also the SDN NFP forum is supporting us. So thank you. And also we have like around 30 people are really actively working on that our ONOS code Korean developer community, and we are kind of giving a like talk about, we are sharing our experience on the use cases and what we are really doing in our company and some institutions like some KIST or also the KIST or GIST. They're really working on ONOS very actively. Yeah, so we are working on very well. I think maybe our Korean ONOS community is kind of, I think it's the best community in the world, I say. All right, so, and the second question?
Yeah, so I think for me, one of the things that's most pressing or most interesting on the roadmap is the gRPC APIs, right? So this will give us the ability to run most of the applications off platform, right? Right now, most ONOS applications are actually injected into the same JVM as the ONOS core. And that kind of leaves us a little bit vulnerable. If an application were to misbehave or to malfunction, then it can also affect other parts of the system. So I think you know, in terms of moving forward into deployments and things like that, it'd be really great if we were able to have these, you know, high bandwidth off-platform applications that, you know, having a high bandwidth interface with the core and can do their work you know, in their own process or in their own container. And this also gives you much more flexibility in how you deploy these things. You don't have to have everything in one place. You can kind of split applications up, deploy them where you want, and then kind of scale them as you want as well. So for me, that's one of the most interesting things going forward.
Yeah, I agree with that. Yeah, the support for gRPC is probably, even though it's something that's been in incubation for a couple of different releases right now, I'd really like to see it, especially in Magpie, to start to materialize in some sort of visible way. Because not only for offloading applications, but also ultimately to disaggregating the ONOS core itself, which I think was actually part of the question that Nicola asked in the beginning, is our ability to be able to disaggregate the ONOS process itself. Without hopefully repeating too much of what John just said, I mean, this will allow us to deploy things and support service scaling, so that you may have different parts of the system that are loaded much more than others, and this would allow you to instantiate different things. Also would add something that ONOS is currently really ill-suited for, which is running tenant-specific applications because of the lack of, I mean, we do have some isolation capabilities, but they're limited compared to traditional networking, operating systems, is to provide better isolation mechanisms so that you can have a Coke and Pepsi to be able to run the same instance of an application without necessarily being impacting each other. Right now, we really can't do that very well.
It's not about specific roadmap evidence or something, but what I would like to see from community is that more people who actually are using hands-on, using the tool to give us more feedback in general. In the past, the BPLS was really went well in a way that they people who are actually running the network were involved in the process, how they would like to see that the CLI and user interface to change over time, and that greatly improved the usability of how the configuration files are structured, how the CLIs are structured. So having the user in the loop of the development process really helps getting the really tangible, usable applications. So we would like to see more and more people speaking up about what their experience, how they want, what kind of improvement they would like to see. That's that kind of thing we would like to see.
Cool. So let me just highlight two current initiatives that are going on in Korea, and maybe they'd be good initiatives to join. The first, which Jono and Thomas both mentioned, the gRPC stuff, is actually led by Jian Li, who Sang-Ho mentioned earlier. They're an active brigade that's currently working on making gRPC interfaces available northbound, eastbound, westbound, etc. The other initiative is the virtualization brigade that's been mentioned a few times. That's led by Yoon-sun, who's now at Samsung. Yeah. So that would be another good local brigade to join as well. I think from my perspective, the personal challenge that I would offer to the community, Korea is known for being an early adopter and having new hardware, new devices. And I think putting that hardware to good use, getting experience with deployments on things like P4 switches, next-gen OpenFlow switches, etc. If those things can go into trials and that feedback can be given back to the community and code contributions, drivers, new applications, etc. For the new hardware, I'd really look forward to seeing that.
Right, thank you. Okay. Any more questions? Okay, great.
This is Lee from ETLI and from SNNF Forum. Yeah, I'm working with that. And I thought the TST means testing.
Really?
I'm really interested about the testing or the quality of this artifact. So the ONOS probably the distribute is for many times on a year. It's 4 or 6. I'm not sure, but would you give your any opinion about the quality of the ONS artifact? It's it is a very simple question, but would you provide?
It's like in terms of like commercial grade quality, right?
Yeah, and then quality, and then about testing. So very I think about a short time to the time the gap of the distribution, but probably brigade testing about things.
I see.
Yeah.
Probably maybe we can answer how we can to guarantee the QA of the quality of.
Sure. I mean, it's definitely a good question, right? So to guard for good quality of the code, it's a kind of a multi-stage effort. First of all, we do engage in sort of manual code reviews to make sure the code adheres to certain style and certain philosophy of design, just to make it more maintainable and so that it kind of looks as if it was written by the same author, even though there may be 200 people writing the code. That's kind of visual aesthetic enforcement. Then there's of course unit tests, which we're encouraging and asking for community contribute unit tests. Now, having said that, our code coverage has dropped since the I think like second release. I think we were probably 50 plus code coverage. I think right now we're at 40, and we would like to eventually actually get to higher code coverage. Of course, generally we would like to have code coverage through unit tests across all types of functionality, but some are clearly more critical than others. Like the distributed code, it clearly needs to be extremely well unit tested. Driver code, maybe not so much, but that's a little bit of a subjective assessment. But clearly unit tests are extremely important. We also have QA within ONF.
there's a group that tests the different releases using their system tests. And we also have kind of modular developer-oriented scenario tests, which we call STC, that developers can use to run in their own environments to just be able to basically make sure that the system continues to operate. And the STC tests are something that we're also now running on our Jenkins machine periodically, but we would eventually like to also make it part of the Gerrit validation build, so that as a developer submits the code, their code will not only run all of the check style and unit tests, but also run the system tests to make sure that something was not broken in ONOS runtime by those changes. Those are just kind of couple of different tiers. Of course, we have had different members of community also run their own test scenarios. For example, I know that Siena is running their own set of test suites somewhere else, and they do end up reporting number of defects and fixing number of defects both in the current master as well as some of the past releases that they're supporting. And there's clearly more work to be done, but yes, quality is extremely important. Okay, thank you. So actually, the code quality and the guarantee the quality of the ONOS is also the role of our community. Actually, so even though they are in charge of kind of the ONOS core, the code quality, but actually they can really review all of the application's code. So we should really test more when we upload our codes. Yeah, I'm trying to do that, but I know it's not really hard. But okay, so all right. So while you are preparing the next question, so I prepared this situation. So I've done some research. Can you please show 제가 보내는 슬라이드 좀 띄워주실래요? So I have done some small, very tiny research. I know everybody knows that SKT is very AI, the intensive company. So using our AI facility, I've analyzed like our ONOS email mailing list. I have analyzed like 10,000 mailing lists, and I have created some kind of word cloud. Is it like upside down? I think. Maybe it's still. Yeah, I think it's upside down. Still, it's okay. So, but actually, I have analyzed only the subject of the email. So in the center, also we have big ONOS, of course. So now we can see what is kind of a main focus, what is kind of a main the concerns, main questions, some from the community. Yeah. So we can see some flows and devices, intents, some clusters, vertical, and a lot of things. Can you please show the next? Go to show the next one. Okay. So now I have picked 100 keywords. Still we have ONOS, bug, intents, flow, driver, device, build. So if you have any, you can pick any keyword from here. That means it's not your only concern. So everybody is interested in this kind of keyword. So you can use this keyword when you ask questions. So okay, so let me pick one question, one keyword from here. So actually, I've been working on also developing Sona, and I'm trying to, I'm a little bit huddling. I'm having some trouble with clustering of ONOS. So I'm gonna pick some cluster keyword. So I know that it's really difficult to implement the cluster. So can you please share what is kind of a big challenge or big hurdle to build a kind of a completely distributed system, and what is kind of a roadmap? What is kind of how you are trying to improve this kind of a clustering system? Is it too difficult? Right?
I think I understand the question, but I just want to make sure I don't talk. So, anybody want to take it?
So I think there's two parts to the clustering challenges, right? One of the parts of the clustering challenges is historically it's been difficult to build distributed systems, right? So maybe I'll let someone else take that part. But the other part to clustering is that it requires a network that has been configured to work together. And the way that ONOS works is that you provide a cluster JSON and a partitions JSON that need to be aware of IP addresses, need to have some management network, and it needs depending upon your deployment scenario, there are different mechanisms and ways that you need to build this thing. There have been some improvements that we've tried. We've made it possible to automatically generate SSL keys for doing secure communication between the cluster nodes. But there's still some opportunity around if ONOS is going to be run in specific environments, if it's going to be run in Docker or Kubernetes.
Right.
Making the process of deploying a cluster more automated. We don't really have as much of that today. So I think that there's definitely an opportunity from an ease of use and bootstrapping perspective to make some enhancements. And if there's people here that are using specific types of deployment scenarios or orchestrators, we definitely would welcome some contribution to contribute scripts or certain rule sets around it.
So quick clarification for the question. So at least as I understood it originally, you asked it was, so there's the deployment of the cluster aspect, which is what
That's
Brian
right, yeah.
answered. But there's also some the internal aspect of developing an application which is itself distributed and how ONOS facilitates it. Did you also have that in mind as part of the question?
Yeah, actually I was in mind a little bit more on the deployment.
Okay.
But still, I can also, you can answer that was a question.
Well, that's fine. I don't want to make a question. I just want to make sure that the question that you asked was fully answered.
Yeah.
So so to add to what Brian said on the external aspect, deployment aspect, I mean, there's definitely changes already being made. We recognize the fact that that there is some manual kind of work required to properly configure the cluster and the partitions if you want to do it in a non-standard way, and especially when it comes to supporting dynamic clustering, that becomes really apparent that if you add nodes to the cluster and don't change the partitions that are, or change it badly, at the very best, you're going to end up with something that's doesn't really necessarily increase your scalability as you add new nodes. But at the very worst, you could potentially break the cluster or even lose the information that you already have by misconfiguring going forward. Basically, the cluster will disassemble. And so, clearly, to prevent that latter scenario, we are adding tools to be able to seamlessly scale the number of partitions as you add nodes in a cluster.
All right. Thanks so much. All right. Do you have any additional question? All right. Great. Oh, with two. Okay.
My name is Shiva. I'm from Samsung. This question is related to cluster only. Like right now, if you have a 3-node cluster, it requires 2 nodes to be active for the cluster to function. Like if one goes down, it can work. But if 2 nodes goes down, then it will. I understand like there is some dependency with the underlying protocol that is being used for this. Like in future, is there any plan like even in 3-node cluster, if 2 node goes down, still the cluster can function? That is my first question. Second question is related to like, what is the plan for this in-service software upgrade? Like in which release that will be available and what will be the status of that?
So I'm going to hopefully briefly answer and then let others add. So to answer the first question, we really don't have any plans to add support for 2 cascading failures on a 3-node. If you want to support 2 simultaneous nodes failing, you need to be able to add 5. You basically need to be able to have 5 nodes in a cluster, and that will get you the required level of resiliency. That's just a brief question to that part. On ISSU, the idea is to add this functionality incrementally, as Ian has mentioned before. So we started by adding ability of the 2 nodes in a cluster who are running 2 different versions of the software to be able to communicate with each other, which is the portable serialization. But that alone is not enough. We also need to be able to, if the stores themselves, stores are the primary mechanism through which the information is disseminated and tracked across the cluster. So the stores themselves, if they change in some sort of deep semantic way, they need to themselves have logic that can deal with 2 different versions. So and potentially even applications that operate on a network or subsystems that operate network need to be able to recognize that they're in the middle of an upgrade and not engage in any changes on the network. And so there is actually a detailed proposal for how the protocol works. The idea is to offload as much of the burden of application as possible, but some participation of the applications will be required to support the ISSU.
I was just going to add to the first part of the question. Having 3-node cluster only supporting one failure is not just a limitation of ONOS. It's actually pretty common across many distributed systems, especially ones that rely on having a majority of nodes to be active in order to write to the cluster. And in those kind of systems, you need, basically to support n failures, you need 2n plus 1 nodes. So if you want to support 1 failure, you need 3 nodes. If you want to support 2 failures, you need 5 nodes. And so it's about choosing how many failures you want to support and then choosing the appropriate number of nodes based on that.
So just to maybe confuse things a bit, not intentionally, but maybe that will happen. ONOS has a few different types of stores, and really the failures of 2 nodes in a 3-node cluster will only really impact the strongly consistent stores. And so in the strongly consistent stores, you may be familiar with the CAP theorem. In the face of partition tolerance, you can have consistency or availability. For the strongly consistent stores, we choose consistency. And so without a majority of nodes available, you can't make forward progress on strongly consistent stores. ONOS also has a notion, though, of more loosely consistent or eventually consistent stores. These stores can continue to operate, sort of, in the face of a majority of the nodes going down. They can't elect new leaders for timestamps, but for making updates to partitions or to pieces of the store that already exist, they can continue to take reads and writes. The other thing is that from like a driver perspective, if, for example, you pushed RPools down to the driver and had the driver just respond with ARPs or something, the individual node in the cluster that's still up could continue to respond without having to do distributed operations in the face of those failures. But there's things like mastership handover that in the face of 2 failures, you wouldn't be able to hand the mastership over of devices that were under the other system. So if you have like a real-time application that you do actually care about availability more than consistency, it's important that you're using, or you've at least cached information locally on that node that would not necessarily require consistent store reads or writes to make forward progress. And then hopefully these failures are somewhat transient, and that when the nodes come back, you'd be able to synchronize with the rest of the cluster.
Thank you. Can I ask one more question? It's regarding data center interconnectivity. In the industry standard, protocols like BGP, VXLAN, EVPN is a de facto standard nowadays. But I don't see much information in ONOS with respect to EVPN protocol, how we achieve it. We have like east-west communication in place, but the overall picture is not quite clear as how we can achieve DCA. Thank you.
Yeah, so that's an area that there's been a team from Huawei and a team from Tech Mahindra that have been working on BGP-based EVPNs over the past year or so. And their code's very recently being contributed to ONOS. I think it wasn't available in the previous release, but it is available in the release that just went out, 1.11. So there now is capability within ONOS to be able to support BGP EVPNs. And the hope was that we could leverage that same code to support other types of VPNs, L3 VPNs, and things like that. So yeah, that's really a recent addition to the ONOS code base.
Also, there's also some activity around MEF, more top-down approach of providing the end-to-end VPN services, which we are trying to adapt in the equal use case. So I think you'll be able to hear more about that on this Friday talk by Francesco.
Thank you.
Okay, thank you. And maybe I remember Frank. Okay, great.
Hello, I'm Frank Wang. I'm from China. I have two questions. The first is I don't know it is right if it is right, but I feel in China, in my company, and my leader heard ODL than ONOS. Do we have a more active marketing policy? Or can we organize more activities, like some meetup? In some times I have to do many times to explain why do we use ONOS so I know ONOS is very good, but I feel its marketing policy is not very good. I think it's not a technical question. So I just put up from here.
I see. So maybe the question is simple: why ONOS? Right?
No. I think I know ONOS is very good. We do a lot of investigation between ODL and ONOS, and I think ONOS is very good. But some guys they do not they don't coding. They heard a lot of ODL is not ONOS. So I think can we do more some promotion or about ONOS
So it's less of a question and more of a suggestion than if I understood correctly. And not necessarily technical one, but more, I think what I heard you say was that you would like to see more events like hackathons or meetups that are ONOS related to increase ONOS's visibility, at least as relative to Open Daylight. Is that correct?
Yeah.
And it's certainly something that we're, as part of the ONOS building, community building we're looking at doing is add more hackathons, more region-based meetups. But that's something that the ONOS ambassador community is working with, and I'll let you add to that.
Sango? Sorry.
Sure, yeah. Thank you, William.
I know you're on the spot. Thanks, Tom. The ambassador program is actually a really critical piece to your question, or answer to your question, because absolutely we need to do much more in China and other parts of the world to organize events or hackathons, bring the community together. There are a lot of people who are very interested in ONOS, who want to get involved, but we need to support local community more. And so the ambassador program is a very effective program so far to really support our communities around the world. And I know that we have about 10 ambassadors in China. 10 sounds, it's like a big number for us, but maybe not so much in China.
China's a big country.
China's a big country. But yes, but one suggestion or one question, not that you can think about, during the ONOS build, is how can we articulate ONOS, and how can we, what can be our message? How can we have a better message in China to reach out to local developers and people interested or who could be interested in ONOS? And the other thing, another important point is for whoever is on WeChat, we have an ONOS WeChat group, and we have about 400 people on the ONOS WeChat group. So clearly a lot of people are very interested. Unfortunately, my Chinese is not very good. It's actually not existent. But so we really need, we would really need to know or try to engage with that group. And I know there's some conversations in that group, but I wish I could, if I could speak Chinese, I could really reach out to them. But anyway, something to think about is how can we, and especially David and myself, we're the community managers at Open Networking Foundation, how can we support that group to really start promoting ONOS and organize more events and meetups in China?
Yes, thanks. So here is another question. So many people in China are very interested in ONOS, but they have it's difficult to contribute something. So here is a request for TST. Can we try to figure out some way to have in China something is blocked. I often meet those things. When I can download some package, I should take a few days to figure the why I can download something. So can we? So this is a problem. I have talked to David and Camilo and Branso. I'm thinking, can we provide some mirror or I don't know. If almost I try to figure it out, I think I can provide some suggestions or can help. Thank you.
All right, thank you for your question. So I think you don't need a clear answer, right? So, right, okay, right. Anyway, thank you for. Do you have anything to mention?
Yeah, so I think we've had these kind of problems on the Quad side as well recently, and one of the things. I mean, this kind of stuff is very hard for us to even know what the problems are because we're not in China and we're not kind of trying to use the software over there. So one of the things is that you guys who are over there, if you figure out ways to work around it or to build things that don't work out of the box, then we should definitely document that and get those things on the wiki. I know that when trying to build the core stuff in China, there was they had to use different Maven mirrors instead of the US-based ones. They had to use Chinese ones because the US-based ones are blocked. So things like that. If it's just a matter of kind of changing the configuration or adding different mirrors or things like that, then that should really be documented, and we should get that on the wiki so that people are able to do this without having to figure it all out themselves.
And for ONOS specifically, I mean, we started as having the only requirement was to be able to clone the repo, and then you should be able to build it, provided you have access to the Maven Central, which was at least reasonably redirectable. But right now we've added, most recently we've added a couple of dependencies. You're probably familiar with them. One of them is on NPM, access to the NPM repos, and one is on Git, be able to download something from GitHub, and which kind of jeopardizes the offline builds because the access to those repos is required to be live during the build process, and that's something that we would like to remedy. The idea is that it might be required once, but once it's cached, then you should be able to run the build offline in kind of an offline mode, which is something that you can't do today. So we'll probably have to fix that, hopefully in Magpie release, if not in an end release.
Right. Yeah, thank you. And nice.
One more question.
Yeah, Chris. Oh, wait. Okay, great.
Okay, I'm Justin from Etri, and I'm very new to ONOS, but I've been working on ODL for a couple of years. And my question is, ONOS didn't support Yang and NetConf in the beginning, but now it does. So I want to know the design choice, the history or story behind supporting Yang and NetConf.
So first of all, welcome from the dark. Welcome from the dark side.
Thank you.
And second, as I mentioned in the talk earlier, actually ONOS supported configuration from fairly early on, because there's nothing to say that the only way you do configuration is through Yang and related NetConf. But of course, we recognize that that is a fairly popular ways of configuring devices, and so we wanted to add a support for developers to be able to do that. The reason we kind of a little bit late is because there was really no good choice for Yang tools that were for Java that were independent of platform. Because as you've worked on ODL, you probably are aware that the ODL that the ODL Yang tool chain is fairly tied to ODL, at least to MD-SAL. And that's clearly not something that we could just blanketly import into ONOS. And so we made the choice to develop our own Yang tool chain to be able to support at least initially ONOS, Yang 1.0. And it was a fairly long process, but we managed to do that, and we managed to do it in a way which actually the ONOS Yang tools are completely independent of ONOS, both at compile time and runtime. So you can actually use those tools completely outside of context of ONOS. So they're, even though they carry ONOS in the name, they're really actually generic Yang tools. And they produce Java artifacts, which allow you to both in a model agnostic and model specific way to build up the information model in memory and then to be able to serialize it into and from XML or JSON at runtime. And so we were a little late in that regard to the game, but we're there now. So what we're still trying to add, which is something that we don't have and where ODL is still ahead, is the ability to store the information in this unified tree store, which currently, ODL has MD-SAL. So ONOS is building something similar to allow applications to be built without having to build their own stores and track the information that they import into ONOS in this centralized tree store. And I will let Yuta add to it on the device synchronization, right? Because that's something that he's working on.
Yeah. So yeah, effectively, like Thomas just mentioned, so the database configuration subsystem is effectively going to be the store where you can store whatever Yang data structure into it. Now, the little bit different thing is that, so Yang itself defines an API, so there is a little bit of a challenge in trying to incorporate that into a global tree, since those are defined as an API for a device versus what almost as a whole, we are talking about the whole network, so we need some level of shim layer adapting that into some subset of things. So we are currently working on the mechanisms to build that thing, and we are trying to come up with an initial version that can speak netconf down to the device, so that whatever anywhere in the network, you can request for something configuration about a device, and eventually synchronize down to the device. That's something we are hopefully deliver in Magpie or the version next following.
And one last bit, which maybe is the history part, which you asked about. And I think the reason why ONOS didn't have netconf to begin with is because ONOS, sort of at its roots, was a controller around the notion of SDN as a separation of data plane and control. And so for control plane offloading, OpenFlow and flow programming abstractions were much more important to us than the ability to configure BGP, ISIS, configure all of these existing networking protocols. And so ODL, on the other hand, kind of has more roots in configuration automation, where taking the existing devices that you have and doing configuration to those devices was more important. And so, obviously there is some degree of configuration that's required, in doing network control. You need to bring ports up. You need to establish some protocols for communication of devices that are legacy devices or devices that are going to communicate outside of your autonomous system or network that's under your control. But really, in ONOS, the focus has been on, and continues to be on, having a strong degree of flow programmability.
Let me add one more thing, is that the dynamic configuration store, while we're definitely pursuing it with fervor, and we want to be able to provide it, is still, at least my and others' opinion, that the abstractions are ultimately still the best approach, and therefore the ONOS, the use of the Yang tools or the Yang models themselves should really still continue to be confined behind the barrier of the drivers and abstractions that the drivers provided. And this approach is actually very congruent with what Google is doing. You can actually watch the webinar which I just gave last week with Anis Sheikh from Google, who's a network architect at Google. The Google's approach is very, very congruent with what ONOS is using. They're trying to keep Yang as buried as possible and away from applications.
Thank you very much.
Thank you. All right, so it's almost 1 o'clock, so we have to take a photo and also we have to have a lunch. So maybe if you don't have any question, then maybe it's time to wrap up. Do you have any final words? No? Okay. Okay, go ahead.
Again, thank you for the good questions, and again, I would like to encourage everybody to everybody to participate with the ONOS TST. We have weekly meetings which we hold with some degree of regularity. Sometimes the meetings get interrupted or postponed because of other events or other things happening like releases. But too often they get postponed due to lack of topics, and so we're very open to moving those to time zones which are friendly to either Korea or European time zones. And so I would encourage everybody here to participate in those meetings and to supply topics, bring discussion to TST, or bring concerns to TST. So again, thank you for the good questions. Thank you, Simon.
Thank you.
Thank you very much. Thank you, everyone. Okay, thanks so much. All right, so we're just about finished for the morning session. 2 or 3 very important points. So again, I'll say it one more time. We are doing a group photo